So any transaction processing system, could be a database, a web server, a load balancer, or a storage system, has a performance characteristics that's something like that. If on one axis you put the latency of the system, the other one you put how many operations it can process, meaning how useful it is to your application, how fast your applications can go. You have that slope of the curve. And it's very simple. You have a task or application wants to do something, and you have computing power that processes that operation. And it's all good. You have a bit of task, the system copes. You have more tasks, the system copes. At some point, you have more tasks for as many tasks as the system can handle. And it's all good. You have, you want to open a web page, you want to run your mobile app, you want to run your SaaS application. It just runs. It's fine. This is the ideal system. Is the more you load the system, if you have performance in the system, it just responds. Real-life systems are a bit less ideal because of caching and queuing. They have this slope. So what happens if somebody comes to your website and it's Black Friday and you have more requests than resources? Well, this is what happens. You have more requests, compute doesn't manage, and on the other side of the system, you have this thing. You hit a plateau, you go in what's called congestion mode. You're not in the elastic mode of the curve anymore. You hit the saturation point, and then user starts to see delay. So they say, oh, your service is slow, it's not responsive, you start to get support tickets, etc. So if you're building a cloud, be it a public cloud, a hosting, VPS, shared hosting, private cloud, you have to know this. This is kind of the theory. And if you want to provide the best service for your customers, you should run a system in the very low load because it's the most responsive. Anything that the user wants to do, they're able to do fast, and they're happy with your service, they recommend your service. If you want to optimize your business, however, you want to run your service just at the point where customers get very good user experience, but you're also utilizing the system to kind of like 99%, because this gives you the best unit economics, the best return on investment. However, you have to be cautious not to go above, because at that point you saturate the system and users start to get very, very bad experience, all of them. It's just not one, all the system, your website, your hosting service becomes irresponsive. So this is how high this line is, depends on what is the system throughput. And when you talk to a vendor, they'll tell you in storage, they quote some performance numbers like IOPS or something. They usually measure this IOPS or this metric that they boast about at the very high spectrum of load of the system, which is totally irrelevant for you because if you're using the system in this mode, you lose most of your customers. So, have this in mind. This is not something very new. It's been known for ages, and I think at some point it just got forgotten. So this is year 1995 described at kind of this reference source. And we just turned it around to show kind of how it looks, very much like the graphic we depicted. So to show our peers in the hosting industry what this means in practical terms, we've done a small experiment. We're taking a volume, in this case a storage system, that can do 10,000 IOPS, input-output operations per second. And we're measuring what's going to be the impact of the application that's running on top, in this case a database. So, for example, we're looking at this block storage service that's coming, in this case, from DigitalOcean, and they say it's very good for running databases. I said, OK, let's see. So this is their metrics. When you go on the website of any hosting company, cloud company, you can see something like this. You're buying a resource, they give you some performance metrics, and there is a price attached to that. And we're looking at the most capable solution, in this case, the 10,000 volume, 10,000 IOPS volume. And we're also comparing it to the peers in the industry. We're looking at DreamHost, DigitalOcean, OVH, which are kind of having different type of latency on this service. The same volume that you can buy from one company, and you can buy the same thing from other companies, have very different latency characteristics, which means very different application performance. Now, we're looking at Amazon because everybody is like, oh, Amazon is the leader in this domain, and they're way faster, like 5 to 15 times faster. However, that volume is 10 times more expensive than the volume you can get from the other company. So it comes at a price. And since we're a storage company, we wanted to see how we were doing. So we measured the performance of some of our customers. And in this case, it's eApps, a US managed hosting company, Togglebox that's competing with DigitalOcean quite nicely, and a heavily loaded shared hosting cluster, a big shared hosting cluster that doesn't sell VMs. They have the newest hardware that you can find on the market, NVMEs, new generation CPUs, and we measure the latency of these guys, and you can see it's faster than Amazon. So we said, okay, that's very nice, but what does it mean for the end user? What does it mean for the person that's running WordPress or something else? Okay, so we said, we'll make a controlled experiment where we get 2 volumes that are running database on top, and in any WordPress and any application you have a database. Both will be able to do 10,000 IOPS, so performance metric, but the only thing that will be different, it will be how snappy, how fast this storage system responds. In one will be 2 milliseconds, the other one would be 0.3 milliseconds. And they're the same VMs. We bought them at different providers, 4 CPU, 4 gigs of RAM. We're running the same standard test, like the pgbench, PostgreSQL, and we're measuring performance. So here we have the 2 VMs side by side. They are same CPU, same amount of RAM, same amount of storage. Both doing 10,000 IOPS. This is 5,000 reads, 5,000 writes about on both sides. And we're looking at what is the performance metric of these systems. Well, one does about 4.5 milliseconds latency. The other one does twice that. The one that's with the faster storage volume does about 1,800 transactions per second. The other one does about half that. So it's 780, I think. And we say, OK, if we start loading this system above what the system is capable of, which is, in this case, we play with 1,200 transactions per second, we see the latency on both of the VMs. One of the VMs that has 0.3 milliseconds of latency on the storage device continues to serve operations, and the latency in the application, in the database, stays about 5 milliseconds. The one that has 2 milliseconds latency on the storage device starts to pile up operations. It starts from, I think here, at about 1 millisecond, and it starts going 5, 6, 7. It continues to pile up, and at some point, the application becomes totally irresponsive just because you saturate the system. So here we've summarized the results. Like the 2 millisecond storage volume gets about 900 transactions per second at 8 milliseconds. And if you ask it to do more, you just saturate the system and you kill your service, basically. The one that's about 10 times faster, it does twice the performance at much lower latency. And if you start loading it, it continues to operate. So back to where we started. If you're running or if you're buying a service from any cloud vendor, you see this table and you're wondering, well, where is my most important metric? Because this is the thing that shows how fast your applications will run, how happy your customers will be. Will they stay or will they go to a different provider? Will they recommend you and you'll get organic growth? Because everybody knows it's extremely expensive to get customers nowadays with affiliates and marketing. So will they spread organically or will they just churn and go to somebody else? And that's never shown on the graphics. Here we've shown a small, we mapped the performance metrics that we've seen under different types of loads of the system. And we have OVH, DreamHost, DigitalOcean, and AWS. And as we saw in the table, AWS is quite expensive, but above and beyond everything that's on the market. So anything that requires a database running in it would live comfortably on AWS and pretty much would not run on the other platforms that you can go and buy. Now, we also put the customers that are running our gear just to compare, and you can see that they're having something that's sitting in their low infrastructure layer, but because it has very, very low latency characteristics, allow them to go above and beyond what is currently possible from or by the market leaders like the big hyperscale providers at much lower cost. So we said, okay, if more people can run their applications 10 times faster, that would be great for everybody. The world would be a better place if everybody can just change one of the application layers of their infrastructure and have 10 times better applications or faster applications. Of course, if they can cache their application, they would cache it, and most companies have already done so. But if you can change one of the components of your infrastructure and have tenfold increase in the performance of everything that you run, it's latency of any storage system, not only storage of any system, would be the one place to look at how can I reduce the latency of the systems that I'm running today. So I think my time is about up, and that was my quick talk. Any questions?